In this video, we're going to cover section 8.2, graphs of polar equations. So the first thing that we should talk about is that you should study the equations and associated graphs in the table on page 599. If you look at that table and kind of memorize those graphs along with the associated equations, it's going to make your work in this section a lot simpler. I am going to do these two problems assuming you have not looked at those, but if you have, you can do these problems in about 1/5 of the time that it's going to take us to do, if not less. So the first question we're going to look at is to sketch r is equal to 1 plus sine of theta. Well, anytime we're going to sketch something, if we don't know what it looks like already, which you would if you had looked at this table up here. But if you don't know what it looks like already, we can plot points and go from there and just kind of sketch. So let's go ahead and do that here. So if we're going to draw some points, we're trying to sketch r is equal to 1 plus sine of theta. Let's plug in some theta values. Suppose I plug in theta is equal to 0. Well, if theta is 0, then sine of theta is 0. So sine of theta plus 1 is 1. All right, what if I plug in pi over 4? Well, let's see. Sine of pi over 4 is root 2 over 2, so we get 1 plus root 2 over 2. Root 2 over 2 is approximately 0.7, so this is approximately 1.7. Well, let's try pi over 2. I'm just plugging in values that we know sine of those values. You could have tried pi over 6 and pi over 3 along the way, but these values work nice here. So plug in pi over 2. Sine of pi over 2 is 1, so 1 plus 1 is 2. We can plug in another one. How about 3 pi over 4? So I'm going up by pi over 4 each time. 3 pi over 4 is also root 2 over 2 when we plug that into sine. So this is again approximately 1.7. We can do a few more here. So how about pi? Plug in pi. Sine of pi is 0. 0 plus 1 is 1. We can plug in 5 pi over 4. And we get sine of 5 pi over 4 should be negative root 2 over 2. So this is plus 1 plus a negative root 2 over 2. So that's approximately 0.3. And how about we plug in 3 pi over 2 next? So again, we're adding another pi over 4. Well, 3 pi over 2, sine of 3 pi over 2 is negative 1. Negative 1 plus 1 is 0. And lastly, let's plug in 7 pi over 4. Sine of 7 pi over 4 is negative root 2 over 2. So this is again 1 minus root 2 over 2, which is approximately 0.3. And now let's draw a coordinate system and plot those points. So let's go with 1, 2. This is a circle of radius 1. And then a circle of radius 2. Close enough? All right, and let's plot those points. So here we see 0, 1. 0 is the angle theta, so that travels in this direction along the positive x-axis. And we have radius 1. So I can plot that point. Okay, pi over 4, 1.7, or really 1.7, pi over 4 if we're going with the r, theta notation. Well, theta is pi over 4, moves in this direction. And 1.7 will be about there. All right, if we plot pi over 2 for theta and 2 for r, pi over 2 moves in this direction. R is 2, so we'll plot that point. Continuing along here, we'll actually see some symmetry start to develop. 3 pi over 4 is our theta. R is 1.7 for the next one, so again, we're about there. And when theta is pi, r is 1. So pi is this direction, r is 1. All right, 5 pi over 4, that is this direction. And we get r is equal to 0.3. So that's there. And 0, 3 pi over 2 for theta, 0 for r, so that's just the origin. Anytime r is 0, that gives us the origin, no matter what the angle is. And then finally here, the last point was 7 pi over 4 for theta and 0.3 for r. So that was in this direction, and we go 0.3. All right, now how do we draw this? This is a cardioid. Why do we call it a cardioid? Well, you'll see that in just a moment. Okay. And if you notice, this right here looks kind of like a heart. And so that's why this type of a graph is called a cardioid. But functions of the form 1 plus sine theta or something similar to that. So a constant plus or minus a constant times sine theta should give us equations similar to this. Again, that's all on the table on page 599, so look at those different variations on the cardioid and different variations of functions similar to 1 plus sine of theta. We do have another example here that we want to go through. We're going to sketch r is equal to 2 cosine of 3 theta. This is something that's going to be called a three-leaved rose. And to draw this down, first thing I'd like to point out is we're going to have cosine of 3 theta over here. Well, since we know cosine of pi over 6, things like cosine of pi over 6, cosine of 0, cosine of pi over 4, cosine of pi over 3. Since we know values like that, what does theta need to be? Well, we need to take these values and divide by 3 to determine what theta should be for what values we should plug in to give us an easy way to draw this equation, or draw this graph. So the thetas we're going to use, we'll write out here. First one, of course, will be theta is 0. If theta is 0, cosine of 3 theta, so 3 times 0 is 0, cosine of 0 is 1, 1 times 2 is 2. Next theta we might want to plug in. Well, if we know cosine of pi over 6, then we can take the pi over 6, divide by 3, so let's plug in pi over 18. Again, why do we do that? Because when we go and we plug it into r is equal to 2 cosine 3 theta, we plug in pi over 18 into theta, so we get 3 times pi over 18. That's pi over 6, so we get cosine of pi over 6. We know how to handle that. So cosine of pi over 6 is the square root of 3 over 2. But then we multiply by 2 and we just get the square root of 3. Continuing in this fashion, let's plug in pi over 12. We multiply that by 3, that gives us pi over 4. Cosine of pi over 4 is root 2 over 2, so that times 2 is just the square root of 2. Plug in pi over 9. Why do we plug in pi over 9? Because when we multiply by 3, we get pi over 3. Cosine of pi over 3 is 1/2. 1/2 times 2 is 1. Again, write down a few more here. Next, let's plug in pi over 6. Pi over cosine of 3 times pi over 6. 3 times pi over 6 is 3 pi over 6, which is 1/2 pi. Cosine of pi over 2 is 0. So 0 times 2 is 0. Next one will be 2 pi over 9. Well, 2 pi over 9, when we multiply by 3, gives us 6 pi over 9, which is the same as 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. Multiply by 2, and we get negative 1. And then the last one here will be 3 pi over 12. We plug in 3 pi over 12, multiply by 3, we get 9 pi over 12, which is the same as 3 pi over 4. Cosine of that is negative root 2 over 2. And so this is negative root 2. And this will be enough to get us started with the 3-leafed rose. But this would have been a lot simpler if we had just known what the 3-leaf rose looked like in the first place. And again, you can determine that by just studying this table on page 599. Well, let's plot those points now. 0, 2, so we're moving in the direction of the positive x-axis, and we go out to a radius of 2. Then we have pi over 18, square root of 3. Square root of 3 is approximately 1.7 or so. So we go pi over 18. We go about 1.7. Pi over 18 is pretty close to the direction of the x-axis. All right, next we have pi over 12. Again, not a steep angle here. And we get root 2, which is approximately 1.4. So it's about here. Then we have pi over 9, 1 here, or theta's pi over 9, r is 1. Pi over 9 is, again, still not a very steep angle. And so we go 1. Go out to a radius of 1, which is about here. The next one is pi over 6, 0. And then r is 0, so that's, if r is 0, that's just the origin. So what we start to see is this arc here, and that's going to be the top half of the rose, or leaf of the rose, that's over on the right-hand side. If we keep going, next one was 2 pi over 9 for theta, negative 1 for r. 2 pi over 9 is approximately this angle. And then we go negative 1, so about here. And then we have 3 pi over 12 for theta, negative root 2 for r. 3 pi over 12 is the same as pi over 4. So pi over 4 is right here, that is halfway through. And so if we go down negative root 2, so negative root 2 takes us back this direction. And we might be able to see a continuation of this arc here. And from here, we want to, I'm going to use the knowledge that we have of what the 3-leaf rose will look like, which again, you can go look at that page on page 599. And this problem finishes out just like this. And then this will finally curve back and give us the bottom arc of the leaf on the right. And we have sketched the 3-leaf rose. that's it for the questions that I want to cover from section 8.2.